Morning to one and all. My name is Krishna Mohan. I am working as an assistant professor in Computer Science Department, Specialization Branch AIML. Today we are going to discuss registers and micro operations, part 2. In the last class, we have discussed what are the registers and how the registers are used for writing a programming language like RTL. And after that, we have seen what are the different types of registers. So each and every register has its own representation, and also we have seen what is a memory address register, instruction register, program counter register. So today we are going to see what are the different types of operations we are going to perform by using registers. What are the different types of operations we use by using different types of registers. First, we'll start with arithmetic micro operations. Arithmetic micro operations. So what are the types of operations we do in arithmetic? We use addition, subtraction, and increment and decrement. Suppose we have two registers. So how to add the data present on the two registers? Or if you want to do some subtraction operation. Suppose if I want to do subtraction operation, I should try to make two registers, that is R1 and R2. I have to subtract the two registers data and I should transfer the data to the another register R1. Likewise, we'll see what are the basic arithmetic operations which we are going to do on the registers. See, the basic arithmetic operations are addition, subtraction, increment, decrement, and shift. Now, we'll start with how the operations are performed by using addition. If you see here, the addition operation, we have taken two registers R1 and R2. So, the R1 contains some bits of information and R2 contains some bit of information. We try to add the data of these two registers and we transfer the data to another register which is R3. See here, it states that the content of R1 are added to the contents of R2. Means R1 is one register and R2 is another register. These two registers contain some bit of information or some data. So finally, once if the addition operation is applied on these registers, the data is stored into R1, that is a third register. Right. Likewise, if you go for the subtraction is most often implemented through the complementation of addition, because directly we cannot make a subtraction between the two registers where we can say R2 minus R1 or R1 minus R2. Here we have to make the complement of a given register or the complement of an addition. Right. So if I take the subtraction, R3 tends to R1 plus R2 plus 1. This is a complement of addition. When you make a complement of addition, that is going to be considered as subtraction. Directly we cannot make as R1 minus R2. So likewise, we are going to make the addition and subtraction. Next, if we go to the increment and decrement operations. Suppose if I say R3 tends to R1 plus 1. Means the data which is containing in R2 should be incremented with 1. Then how should I write? I should try to write R3 tends to R2 plus 1. Means we are trying to increment the data which is present in the register R. Likewise, if I go to the decrement operator, that is R2 minus R1. Means we are decrementing the data which is present in the register R2 and assigning the data to R3. Once if the decrement operation is applied, we are transferring the data to R3. Likewise, in the increment operator also, when I try to do the increment, once if the increment is done on the register R2, the data is transferred to the R3. So, we are trying to do the arithmetic operations like addition, subtraction, increment, decrement and shift operations. So, we are trying to make the two complements, that is add with carry and subtract with borrow. Suppose if we do an addition operation, we are trying to do with the carry. Suppose if I take two numbers, if I am trying to add, we can try to calculate or we can try to borrow the data from the other bit of information which is stored in the register. Lastly, we'll try to see the negation, that is 2's complement. Negation means 2's complement. How the 2's complement will be done? Suppose if I take a register R1 and if I am trying to make a complement of that, that is going to be considered as 2's complement. That is means the negation of the given number. Right. The next type of logical operation, the next type of arithmetic operations, or the next type of operations basing on the register. So in the last class, if you remember, we have taken one as arithmetic operation. First operation as arithmetic operation. Second one, we have considered it as logical operation. And the third one, we are considered it as shift operation. So these three operations we are going to perform on a given registers. So initially we have seen how the arithmetic operations are carried out and what are the different types of operations we have in the arithmetic. Now we'll try to see how the types of logical operations are implemented. See, the logical operations mainly depends on and or. And operation and or operation. So how this AND operation is performed on the register and how the OR operation is performed on the register. And if we move forward, we'll try to consider how the XOR operation is also going to be performed. Now, if I start with AND operation and we take two registers, that is we are taking R1 register and R2 register. If I want to apply the AND operation on these two registers, we'll try to implement AND between R1 and R2. And between R1 and R2. See here, if I see the example, R3 tends to R1 and R2. Combinedly, whatever data is present in R1 and R2 stores into the register R3. So this will consider it as AND operation. Next, if you go to the OR operation, it performs bitwise between the two registers. OR operation between the two registers. Suppose if I consider the register R1 and I will consider another register R2, these two registers are considered and they are going to apply OR operation. The data which is going to get as an output is transferred to R3. So that is a second major logical operation which we can perform. The third one is XOR operation, or we will call it as exclusive OR operation. How this operation is applied? The operation of this is going to be considered as use of bit toggling and comparison. That is R1 or R2. Means the data present in the R3 may be from R1 or maybe from R2. If we see the previous operations AND and OR, here we are trying to combine. If we go with the AND operation, and if you are going to the OR operation, we are trying to take the common elements or the common bits which are present in the register. But coming to the XOR operation, it is toggling. That is, if I say it as R1, means the data R1 will be transferred to R3, or the data of R2 will be transferred to R3, but not both, or but not the common bits of the registers. Right. Next. The next one is NOT, which is complement. Complement in the sense, if I say R1 tends to not R1. Negation, we will call it as negation. If I say R1 register, whatever bits present in the register, suppose if the register bit contains 101, 1001. If I make it as complement, I will call it as 010. So in this way, we are going to transfer or in the place of register, we are trying to make the exact opposite of all the bits which are present in the existing register. Next, the fifth bit or the fifth operation which we are going to perform on the logical operations is clear. So how to make the data which is present in the register as clear? Suppose if a bit or register contains R3 contains some n number of bits. And also I want to transfer the data from R4 to R3. Suppose if I want to transfer the data from R4 to R3, the R3 should be clear. The previous data which is present in the R3 should be clear. So to make it clear, I should try to apply an operation which is incorporated in the logical operation considered as CLR. Once if we apply this clear, the register gets cleared. Whatever data which is present in the register previously will get erased and we can add the new data to the existing register, or we can transfer the new data to the existing register. So these are considered as different types of logical micro operations which we are going to frequently apply on the registers. First one is AND operation, second one is OR operation, third one is XOR, fourth one is NOT, and the fifth one is clear. And the last one is set operation. What is the set operation? Sets all the bits registered to 1. So if I want to set all the registers data to 1, what I should do is I should try to apply the register operation which is set, where the registers will set the operation or will set the data to the condition as 1. Now, if you see the list of operations here, the 16 logical micro operations, how these 16 logical micro operations are implemented by using a truth table. We have to consider a truth table from F0 to F15. So all these F0 to F15 functions consider the different types of logical operations which you are going to apply on the registers. So the operations which we have considered as AND, OR, XOR, NOT, clear, and set, these are the basic operations which we use frequently. Apart from these, we have different types of operations other than these. Those list we are going to identify in the Boolean function B0 to B15. If you see here, F0 is 0. The micro operation which is performed on this is clear. And again, if I go to F1, that is X and Y, XY. So it indicates, XY indicates AND operation. Next, if we go to F3, X, Y dash, where F tends to A and B dash, that is B negation. Likewise, we are going to consider all 16 operations of the logical where they are apart from the regular operations. So the regular operations will be considered as AND, OR, XOR, NOT, clear, and set. Right. The third one is shift operations. So previously we have seen what is arithmetic operations, and now we have seen what is a logical operation and what are the different types of logical operations we perform. Now we'll try to see how these shift operations are implemented and how the shift operations are implemented on the registers where the data is available. Now if you see here in the table, we see shift left register R, and the second one is shift left register right. Means the data which is present in the register, can be moved to the leftmost position or it can be moved to the rightmost position. So for that we apply this SHLR and SHRR. Here the L indicates the left and R indicates the right. Likewise, if we go to the next two operations, circular shift left right and circular shift left register right. See here also, if I say it as L as left, means circular shift means whenever the data is present on the register, it can form a cycle where the data starts from one position and again ends in the same position. Suppose if the bit starts from 0 and again if the cycle formed by that particular register and again it comes back to the 0 position, it is going to be considered as a circular shift left, and if it is performing the operation on the right hand side, it is going to be considered as circular shift left right. Likewise, if you go to the other operations, that is fifth and sixth operations, if you see arithmetic shift left and arithmetic shift right. So how this arithmetic shift left and how this arithmetic shift right are represented? ASHLR, ASH indicates arithmetic shift, L indicates the leftmost position, it is moving to the leftmost position. ASHR indicates the data is going to move to the rightmost position. So majorly these 6 are going to be considered as the major operations which are performed in the shift operations. Once if you see the arithmetic, logic and shift, ALS. So all these operations are performed in the ALU, that is arithmetic logic unit. Means arithmetic performs whatever operations like addition, subtraction and the increment and decrement operations. When you go with the logic operations are AND, OR, shift, NOT, XOR, like that. And the third one, which is considered as shift operations, where the shifting of operations or shifting of data in the register may be to the leftmost or to the rightmost. Right. Next, if we see what is arithmetic logic shift unit. So what is this ALU? A very important component which is playing a critical role when you go to the digital computers. So what is this ALU indicates? ALU indicates arithmetic logic unit, or ALS, arithmetic logic shift unit. So if I say it as ALSU, an arithmetic logic shift unit is a computer architecture, is a core CPU digital circuit, because whatever operations you are going to perform, whatever operations we are going to do in a computer or in a digital circuit, this particular ALSU plays a very important role, because all operations are executed only in ALSU. Right? When this particular ALSU is going to give the output for us properly, then only the output is performed on the digital components. The digital circuit that performs arithmetic add and subtract. And if I go to the logical AND or NOT, and if I go to the shift operation, left shift and left right. All these binary data forms on the registers, which is acting as an enhanced ALU. So all these operations in the ALU is performed by using some registers. So these registers, each register has some own importance. As I told you yesterday, as we seen the ALU part, what are the different types of different registers we have? That is PC, that increments program counter. And again, if I say AR, address register, where the address should be stored, that also will be stored in the register. And if you move forward and if I say it as MAR, memory address register, so the memory address register is also playing a critical role, where all the addresses or all the data of the registers is stored. Likewise, the efficiency of the functions and the single operational unit using multiplexers selects the different types of micro operations. And after selecting these different types of micro operations, the data transfer between the register is done by single clock. Whenever we go for an operation execution in a register, the registers should be controlled by a timing clock or a signal. Suppose if I say it as a timing clock or signal, that is 1 and 0. Suppose if I say 1, the operation is executed. If I say it as 0, the operation is stopped. Means it is a flip-flop, 1 and 0. Whenever the operation is executed, it indicates 1. Whenever the operation is stopped, it executes 0. Likewise, the signal is passed to the registers, where the register performs different types of operations. What are the key functions which are performed by ALU? The key functions performed by ALU. First operation or the first key function performed by ALU is arithmetic operations. So what are those arithmetic operations? Arithmetic, subtraction, multiplication and division. So if you see, these two are very less frequently used operations. We directly go for addition and subtraction operation. Apart from addition and subtraction operation, we will go for the increment and decrement also. Next key function of ALU.